A for loop is a way to repeat a block of code a known number of times. Think of it like a kitchen timer that ticks down from a start value to a finish value, ringing each time you press the next button. For open parenthesis int I equals 0 semicolon I less than 10 semicolon I plus plus close parenthesis open brace comment body, executed 10 times close brace. Int I equals 0, the initialization step, runs once before the loop starts. I less than 10, the condition tested before every iteration. If false, the loop ends. I plus plus, the iteration step, executed after each pass through the body. For I in range 0, 10 comment range produces 0, 1, 9. Comment body executed 10 times. The range function creates the sequence, and the for keyword simply walks through it. 10 times do pipe I pipe. Comment body executed 10 times I goes from 0 to 9. End. All languages share the same idea. Set a start, check a stop, move the counter. A for loop is actually 3 tiny programs glued together. Initialization sets up a variable or several that will be used in the loop. It is executed exactly once. Example, int I equals 5 puts the counter at 5. Condition, a Boolean expression evaluated before each iteration. If it returns true, the body runs. If false, the loop stops. Think of a traffic light. Green true lets cars go, red false stops them. Iteration or update expression runs after each execution of the body. Usually it advances the counter I plus equals 2, I equals I times 2. This is like a conveyor belt moving the next item into view. Why separate them? Because you can place any expression you like. For open parenthesis int I equals 1, j equals 10 semicolon I less than or equal to j semicolon I plus plus j minus close parenthesis open brace I moves up, j moves down simultaneously close brace. The loop stops when I less than or equal to j becomes false, that is, when the two counters cross. Explanation: when we talk about time complexity, we ask how many basic steps does the loop perform as the input size grows. For a single for loop that runs from 0 to n-1 with a constant time body, the count of executions is exactly n. In big O notation, we write O of n. Mathematically, T of n equals sum from I equals 0 to n-1 of c equals c times n, where c is the constant time of the body. For example, 1 addition. The linear factor n dominates, so we drop the constant and write O of n. If the loop's condition or update is itself dependent on n in a non-linear way, the count changes. Example of a loop that halves n each time. For open parenthesis int I equals n, I greater than 0, I divided by equals 2 close parenthesis open brace O of 1 work close brace. Here the number of iterations is floor log base 2n plus 1, so the complexity is O of log n. A nested for loop is a loop inside another loop, like a stack of plates. You finish the inner stack before moving to the next plate on the outer stack. Depth: the depth is the number of loops layered together. Two-level nesting is common. For int I equals 0, I less than n, I increment. Inside that, for int j equals 0, j less than m, j increment, then call work function. The total work is the product of the two counts, n times m or big O of n times m. Arithmetic series pattern. When the inner loop runs a linear number of times that depends on the outer index, you get an arithmetic series. For int I equals 1, I less than or equal to n, I increment. Inside that, for int j equals 1, j less than or equal to I, j increment, then call work function. Total iterations equals the sum of I from 1 to n, which equals n times open parentheses n plus 1 close parentheses divided by 2. This simplifies to big O of n squared. Geometric series pattern. If the inner loop bound grows exponentially with the outer index, you get a geometric series. For int I equals 0, I less than k, I increment. Inside that, for int j equals 0, j less than 1 shifted left I bits, which is 2 to the power of I, j increment, then call work function. Total work equals the sum of 2 to the I from I equals 0 to k minus 1, which equals 2 to the k minus 1. If k equals log base 2 of n, the whole nest runs in big O of n time. Explanation: even seasoned programmers fall into off by 1 traps, which happen when the loop runs 1 time too many or 1 time too few. Looping over an array of length len, Typical mistake, for int I equals 0, I less than or equal to len I plus plus. Correct form, for int I equals 0, I less than len I plus plus. Counting from 1 to n inclusive. Typical mistake, for int I equals 0, I less than n I plus plus, which starts at 0. Correct form, for int I equals 1, I less than or equal to n I plus plus. Nested loops where inner bound depends on outer index. Typical mistake, for int j equals 0, j less than or equal to I, j plus plus, which runs I plus 1 times when you need exactly I times. Correct form, for int j equals 0, j less than I, j plus plus. A good habit is to write the range in words first, process items 0 through 4, and then translate it to code. Drawing a tiny table of index values helps visualize the exact range. Mathematicians love to replace repetitive code with a summation because it reveals the underlying pattern. Int cnt equals 0, for int I equals 1, I less than or equal to n. I increment, for int j equals 1, j less than or equal to I, j increment, cnt plus plus, 1 unit of work per inner iteration. Each inner iteration adds 1 to cnt we can write. Cnt equals the sum from I equals 1 to n of the sum from j equals 1 to I of 1. The inner sum from j equals 1 to I of 1 equals I. Substituting gives Cnt equals the sum from I equals 1 to n of I equals n times open bracket n plus 1 close bracket divided by 2. The same process works for more complex bodies. Replace the body with an expression f of I, j and so on, and nest the sums accordingly. Matrix multiplication. To multiply 2n by n matrices A and B into C. For int I equals 0, I less than n, increment I rows of C. For int j equals 0, j less than n, increment j columns of C. C sub I sub j equals 0. For int k equals 0, k less than n, increment k dot product. C sub I sub j plus equals a sub I sub k times b sub k sub j. Close brace. 3 nested loops leads to big O of n cubed operations. C sub ij equals the sum from k equals 1 to n of a sub ik times b sub kj. Bubble sort. Bubble sort repeatedly steps through a list, swapping adjacent out-of-order items. For int pass equals 0, pass less than n minus 1, increment pass outer passes. For int I equals 0, I less than n minus pass minus 1, increment I inner scan. If a sub I greater than a sub I plus 1, then swap a sub I with a sub I plus 1. The inner loop length shrinks each pass, forming an arithmetic series. The sum from p equals 0 to n minus 2 of n minus p minus 1 equals n times open parenthesis n minus 1 close parenthesis divided by 2. Thus bubble sort runs in big O of n squared time. Explanation. Question 1 dash trace a simple loop. Int sum equals 0, for open parenthesis int I equals 1, I less than or equal to 4, I plus plus, close parenthesis open brace, sum plus equals I times 2 close brace. What is the final value of sum? Write down the value of I and sum after each iteration. Question 2 dash find the off by 1 bug. Numbers equals open bracket 3, 5, 7, 9 close bracket. For I in range open parenthesis 0, length of numbers close parenthesis colon. Print open parenthesis numbers bracket I plus 1 bracket close parenthesis. Explain why this code crashes and correct it using the smallest possible change. Question 3 dash nested loop counting. Int cnt equals 0, for open parenthesis int I equals 1, I less than or equal to n. I plus plus close parenthesis open brace, for open parenthesis int j equals I, j less than or equal to n, j plus plus, close parenthesis open brace, cnt plus plus, close brace close brace. Express cnt as a mathematical summation, and give a closed form formula in terms of n. Question 4 dash debug matrix multiplication. For open parenthesis int I equals 0, I less than n. I plus plus close parenthesis. For open parenthesis int j equals 0, j less than n, j plus plus close parenthesis. For open parenthesis int k equals 0, k less than n, k plus plus close parenthesis. C bracket I bracket j bracket equals a bracket I bracket k bracket times b bracket k bracket j bracket semicolon. The result is wrong. Identify the logical error and rewrite the inner statement correctly. These types of questions test the ability to step through code. spot common range mistakes, convert loops to formulas, and reason about algorithmic correctness.